Hello, algebra students. This is your favorite Mr. Bulger. That's me. Oh, something real cute. My cousin has a toddler who just calls me B. She doesn't, she couldn't really figure out Sean or cousin Sean, so she just called me B, and it was adorable. Anyway, oh, my heart. Okay, focus. Number one. Okay, what we're trying to do is we're just trying to simplify. We're not trying to solve these. So this has a lot to do with finding the least common multiple and then combining like terms, right? So that's going to be the first thing, and then choose to combine. Okay, for this first one, the least common multiple is x plus 2. I have x plus 2 in my denominator over here, so I just need to have it over here. So what I'm going to do is I'm going to multiply both sides, or this top and bottom, by x plus 2, giving me 4 over plus x over x plus 2. Multiply this through and combine. Tell me what it simplifies to. That one's pretty straightforward. I think you guys will have no problem with number one. But number two, it's a little bit more difficult. Now remember, I said that when we have multiple fractions, the kind of the most clear division is the one that we're from which we're going to separate these two. So what this actually is saying is x squared minus r squared divided by this business, x minus r and x plus r. Okay, well, if we keep change flip, that's going to be x squared minus r squared times, flip this. Ooh, we have a lot of x's. I'm going to make this a dot x plus r over x minus r. See what I did there is I flipped that. Okay. Well, what we'll hopefully be able to do is simplify this so we could eliminate, rather than multiplying this all the way through. And let's see if we could simplify this. Let's see if we could cross cancel. Well, since we know our perfect square formulas, we know that anytime we have an a squared minus a b squared, the factors are a plus b and a minus b. A plus b, a minus b, right? Chapter 9 coming through again. So this guy, factors, I'm going to rewrite it over here, into x minus r, x plus r, times x plus r over x minus r. Well, when we have something like this, we can cross cancel, and we're given, which leads us to x plus r. Well, essentially it's x plus r, which is the same as x plus r squared. Okay. Nice little simplification. Let's move on. Number 3. Okay, number 3, it's ugly. What we first need to do is we're going to combine these guys and those guys before we divide. So let's do that. On the top, my denominator has to be x. So I'm going to multiply both top and bottom by x, which is going to give me x over x minus 1 over x over, I'm going to need to do the same here. What's nice is it's 1, so it's going to be x over x plus 1 over x, which is going to give me, after combining, x minus 1 over x over x plus 1 over x. Oh, wait, that should be way out. Okay. Now I need to take this whole bottom piece and bring it off to the side as division. Okay, what that's going to look like is x minus 1 over x divided by x plus 1 over x. Okay. Well, now what I'm going to do is I'm going to keep change flip x minus 1 over x times, I'm going to flip this guy, x over x plus 1. Well, now I could cross cancel. Well, this x plus 1 and x minus 1 can't cancel, but I could cancel this x with this x, and then multiply across, giving me x minus 1 over x plus 1. Now, because I've got a minus 1 and a positive 1, I can't really cancel those out, so that's my answer. That's my simplified answer. Didn't mean to do all this work out for you guys, but hey, you're welcome. Okay, now these are actually going to be a little bit easier. If you remember my notes, especially 13.6, you saw like, oh, it's actually a lot easier. So I'm not going to work these out all the way for you, but I'll get them started. Again, we're trying to solve for, in this case, it'll be x. In this case, it'll be y. Okay, so this first one, what I'm going to do is I'm going to take this and multiply it over here. That's going to give me 3x plus 5 equals 4x minus 1. Okay. You guys are going to have to distribute that and solve for x. I think you guys got it. This following one. Again, if we had our least common multiple, it's going to be 2y plus 3 times y minus 1. Well, in order to get this in the denominator, I just need to multiply this side by the top, all right, top and bottom. What it ends up being is I'm multiplying this by 2y plus 3 because it cancels out with that guy. And I'm multiplying this by y minus 1, and it cancels out here. So this gives me 6y minus 1 equals 3, 2y plus 3. I don't know why my camera is following my hand. That's really distracting. Forgive me. I don't know why it's doing that. Okay, now the unfortunate thing with this one is after multiplying it, we get 6y minus 6 equals 6y plus 9. Well, if I subtract 6y, that just gives me negative 6 equals 9. And that is not true, meaning no solution. So the answer is no solution. Again, what happened was I have 6y minus 6 equals 6y minus 9. Whether I just subtract the 6y from here or from here, it eliminates the y value. Meaning in the short term that these functions do not intersect. That's what it means. You don't really need to know that, at least not yet. For our purposes, the answer is no solution. Okay, again, number 6. Number 6 is actually going to be a lot easier than it looks, so I'm going to get you guys started on this. Again, we look for the least common multiple, which we know it's going to be the bottom times the bottom, so x times x plus 1, which happens to be, so this is our LCM, which already is my denominator here. Meaning I need to multiply this guy by x plus 1 and this guy by x, eliminating, or which will effectively eliminate the denominators. Right, if I multiply this whole thing by x squared plus x, I'm effectively eliminating the denominators, but I'm multiplying x plus 2 times x plus 1, subtracting 4x, right, multiplying there, equals x plus 5. Okay. Foiling out this business here will give me x squared plus 3x plus 2 minus 4x equals x plus 5. Okay. Again, we're going to solve for x. I'll let you guys work it all the way out. I believe you'll be able to solve this with the diamond problem. So again, combine like terms, use your diamond problem, and now again, you want it to equal 0, so you need to move all this business over there before you can use the diamond problem. I think you guys will be able to figure it out. Give me both x equals this, comma, that, and then I think we're going to go over this Wednesday in our meeting. Otherwise, guys, I love you so much. I miss you a bunch. Hope you're doing well. Bye.